So dear students, the topic for today will be dielectric and polarization. So firstly we will discuss what are dielectrics, then only we'll go to polarization. So firstly dielectrics. So dielectrics are are substances which are electrically insulators or electrical insulators. So dielectrics are basically electrical insulators, which means they do not conduct electricity. And these dielectrics are broadly divided into two categories. Number one are polar dielectrics, and number two is non-polar dielectrics. Polar dielectrics and non-polar dielectrics. So firstly we'll discuss what are polar dielectrics. Then we'll go to non-polar dielectrics. So polar dielectrics are electrical insulators or substances whose net dipole moment is zero, but it will have its independent molecular dipole moment non-zero, meaning the compound as a whole or a substance as a whole has zero dipole moment, but if you see independently to a single molecule, then it will have some its net dipole moment. The dipole moment will not be zero in that case. So examples are, let us take examples. Your water is a good example of polar molecule or polar dielectrics molecule. So this wholly depend upon the structure of the molecule itself. For example, the structure of water molecule is this one, and we know here your oxygen is highly electronegative, so it will tend to attract the bonds more towards itself. That means then the oxygen becomes a slight del negative, but hydrogen becomes del positive and hydrogen becomes del positive. That means there is a dipole moment from negative to positive direction, and from here negative to positive direction. So the net of this two will give me dipole moment in this direction. So this is the net dipole moment, direction of net dipole moment of a single water molecule. So if you have a bulk water, what happens is your individual dipole moment orient randomly. Suppose for this molecule it has a dipole moment in this direction, then for another hydrogen molecule it will orient in this direction, for another it will orient, for another it will orient. So the individual dipole moment orient randomly this way, so is that the net dipole moments become zero. Net dipole moment become zero. Is zero. So it has individual dipole moment because oxygen being highly electronegative, it will for according to its structure of the water itself, it has some dipole moment, possible dipole moment, molecular dipole moment, which is non-zero. But as a whole, as a bulk as a whole, this dipole moments orient randomly in all directions, such that it's all the effects of this dipole moments cancels each one, so as that its net dipole moment becomes zero. So such type of dielectrics are known as polar dielectrics. So polar dielectrics are dielectrics whose net dipole moment will be zero, but But if you see in a molecular level, it will have some dipole, non-zero dipole. Another one is your non-polar dielectrics. Non-polar dielectrics. So non-polar dielectrics are dielectrics whose net dipole moment will be zero in the molecular level itself. That means it has no net dipole moment at all, even in bulk level, substance level, or even in the molecular level. Its net dipole moment will be zero. Examples are, let us take carbon dioxide. This is a good example. So the structure of carbon dioxide is this one. If this is oxygen, this is oxygen. If this is carbon, if this is carbon. So this is your or in bone structure we can make like this. This is oxygen, this is carbon, this is carbon. This is your carbon dioxide, CO2, sorry. Two oxygens, one carbon. So two oxygens, one carbon. So this is one carbon, these are two oxygens. Or in structure from its bonding structure, it looks like this. So here what you see is this is a little del negative, this is del negative, carbon becomes little del positive. So dipole moments orient in this direction from negative to positive charge. Here dipole moment orient from this to this direction. So what you see here is this dipole moment perfectly cancel this dipole moment, because this dipole moment is towards this direction, this dipole moment is towards this direction. So is that net dipole moment will be zero even in the molecular level. So such type of molecules do not have net dipole moment to be zero. It do not have any dipole moment oriented in any direction. So this is your carbon dioxide. It do not have any dipole moment oriented in any direction. It has molecular dipole moment oriented in random direction, but its net effect is zero. But for a carbon dioxide molecule or non-polar molecules, its molecular dipole moment itself will be zero. Hence, there is no question of dipole moment at its bulk level. So these are the two types of dielectrics. So we are going to study about them in next chapter. Sorry, next section we are going to study more about them. Thank you.